Ted, did you write the book with someone else? Who is it?
Austin Parker.
How do you write a book with another person?
So the way we wrote that one together was we just came up with the outline, and then we're basically like, evens are mine, odds are yours.
You trade off
Wrote
pages?
the rough draft.
Not pages,
And
surely.
then
2 pages.
switched. Yeah, pages, words. Yeah, every other word. Yeah, it's like pair programming. Yeah, that's how we did it. So we each wrote a rough draft of like every other chapter, and then handed them to each other and edited each other's chapters, and then we're like pretty much done.
Nice. Who published that?
O'Reilly.
It's very nice that that you've got an official Chinese one, because I have a book and it was translated unofficially into Chinese. It's just kind of stolen, but I sort of don't mind it. Really, it's sort of open source, I guess.
Sure, as long as people are reading it.
Yeah.
But yeah, no, it's been officially translated into a number of languages, but 2 I know of are Chinese and Russian were 2 where I think, because maybe it's going through a third-party distributor, they ping me about getting a copy of it.
Is there like a British English version where you spell the colour with the U and things?
Yeah, yes, definitely.
Good.
A Canadian one, eh?
Yeah, Canadian one's more polite. So that's very cool, the book. How did you get involved with OTel?
I'm one of the co-founders of the project. So OpenTelemetry was originally formed by merging 2 projects, OpenTracing and OpenCensus. And I'm from the OpenTracing side of the family. But even OpenTracing and OpenCensus are 2 versions of the same kind of set of technologies coming out of Google, namely Dapper, a system called Dapper that was a tracing system designed by Ben Siegelman, and there was a metric system called Monarch. There was another metric system called Borgmon, and Prometheus is based off of Borgmon, and a lot of the metric stuff in OpenTelemetry is based off of Monarch. And internally within Google, there was this total like Borgmon versus Monarch slap fight. And then unfortunately, people who are really invested in that slap fight like have continued to like perpetuate it. I would argue this is the one conspiracy theory you'll get out of me today.
We said no conspiracy theories.
The Prometheus and like OpenTelemetry like shade is like mostly powered by like an internal Google slap fight over like Borgmon versus Monarch. That's my conspiracy theory for the day. It's actually mostly like internal Google nonsense that's like filtered out into reality. And there's plenty of people who will like disagree with me, like, no, the problem is you're evil or something. But not really. But but really, like, that is actually like 2 different like approaches within Google that turned into 2 different technologies. And it's like the same, but like the same Bikeshed nonsense that we're kind of stuck with. But it all came out of Google. So everyone should just get along at this point, in my opinion.
So that's very cool. So for anyone that hasn't seen this before, then what is OTel? We did do an episode on this, didn't we, Matt? Last season.
We did.
Yeah. Who was in that?
That was. Hold on. There was Daniel Gomez Blanco, and Drossi.
So go and listen to that. But for anyone that doesn't know, just briefly, Ted, what is OTel?
Yeah. So OpenTelemetry is a telemetry system. So you could think about this as a new way of dividing up the observability stack. We used to divide the stack up by signal. So you would take one style of observability, right, like tracing or logging or metrics or profiling, and then you'd be like, I'm going to make a logging system. So I will make a logging format, and then I will make a logging API and a logging client to generate those logs and something to process them. And then I'll make a database to store those logs, and then like a UI for looking at the logs in that database. And that's my logging system. And then someone comes along and is like, now I want a metric system. And they redo all of that work, but just for that metric system. the new kind of way of dividing it up is to say there's telemetry, there's applications and systems and computer resources, and they're all self-describing. They're all just describing what they are doing. And when they're describing what they're doing, they are all trying to speak the same language, because when you're trying to understand what they're doing, you're never looking at any of these pieces in isolation, right? You're looking at them together. So if they can all speak the same language to describe what they're doing, then it'll be a lot easier to form a comprehensive picture. And since we're talking about describing what computers are doing, and mostly what computers are doing are like standardized, right? Like talking over network protocols and things like that. It stands to reason that it should be possible to standardize the language that systems are using to describe themselves. If you wanted to do that, you would want to decouple it from things like analysis and storage and like user experience stuff. All of that is kind of greenfield. You want to like keep on developing that stuff. But the actual data, you maybe would want to look at standardizing. And so that's kind of the new way of slicing up observability, is to say we have telemetry, which we want to standardize and we all want to share. And then we have analysis. And analysis, we all want to compete. Now more than ever, with like machine learning and AI really taking off, it feels like open season. Like no one has the perfect paradigm for like taking all of this data together into one system and like doing some really interesting, correlation analysis and stuff on it. There's like a lot of greenfield there. And the fact that people don't have to change telemetry systems, they don't have to dump a huge pile of instrumentation and then re-add a whole new pile of instrumentation. They don't have to do any work to switch analysis tools. I think it's actually accelerating the rate of invention in the industry, right? Because the cost of moving or adding on a second or a third tool is so much lower now. People are more adventurous, looking for new tools.
So how would you say that shows up? So, like what are you seeing in teams that are the more adventurous teams?
Yeah. So one thing I'm seeing showing up more than anything is people actually adopting distributed tracing, and in a way replacing logging with distributed tracing. Traditionally, logging and distributed tracing get talked about like they're these two totally separate things, but that's really this kind of like human historical accident. It's why I really don't like the 3 pillars metaphor. We're like, there's the 3 pillars of observability, tracing, metrics, and logs. And I'm like, well, one, no one ever used tracing because it's too hard to install. So outside of a couple of like big companies, no one used it. So it's like,
but we made all this merch with pillars. You can't just throw the merch away.
Right. But like, but it sounds like we designed it this way. Like this was like a great design to have these data streams completely siloed from each other with like no way to cross correlate between looking at the events, right? The individual events happening in my system versus looking at aggregates of events, AKA metrics. You'd think you'd want to like integrate those two experiences. And so now we're doing that as an industry where like the data is integrated, and we're discovering that like, wow, tracing and logs are really like, tracing is just logging with the context that you always wanted for your logs. Like, what transaction are these logs a part of? It's crazy to me how many decades went by without us being able to just look up the other logs in the same transaction. Right. It's kind of wild that you can't do that.
So are you like the guy at the party when, who comes in with the more existential questions? Like, what if just like logs and events were really traces? Everyone's like, go home. Like,
see, it's kind of the opposite. Like, I hate being existential about this stuff. It's almost like I feel like I struggle uphill against ideology because people have already pre-bucketed what these tools are like useful for. And I think that ends up kind of blinding people to like in a lot of people's heads, tracing is like a latency analysis tool. And it's really expensive, which means you have to do a lot of sampling. And because you have to do a lot of sampling with tracing up front, sampling's really not useful for like firefighting or root cause analysis because you just don't have the data, unlike in your logging system where you keep everything. And we're like, the only reason tracing is heavily sampled is because people were trying to add it on top of a really expensive logging system that stored everything but had no trace context. But they couldn't touch that system and add trace context to it. So they built like a second logging system called tracing. And then since that thing had only a tiny amount of resources left over from the logging system, it was like heavily sampled to do some latency analysis. So it's like, that's just like a historical accident that we built it that way. That's not because tracing and logging are like really like different from each other.
Do you think that if the fundamental architecture was different, that distributed tracing would have gotten traction sooner?
I think the hardest thing with distributed tracing is installing it, because the context that you're getting from it, the really valuable context, is the execution flow that you're following. But language runtimes don't really give you a way to follow that execution flow effectively from an observability standpoint, right? Like if you just rely on thread locals in languages that have threads, you might get some of it, but work often switches railroad tracks, right? Like work will move from one thread to another, or a set of threads will get organized into some kind of like scatter gather thing or something like that. Or an entire like userland coroutine asynchronous system will get laid on top of that. And so actually tracking that flow of execution, that's the trickiest part of OpenTelemetry in every language, is this context propagation mechanism that we have to come up with. And then every single piece of instrumentation has to use the same cross-cutting mechanism. That's harder to roll out and get value out of than logging or metrics, where I can just roll out metrics in this corner just for me, just to monitor this one thing, and I get value. If we're saying the value of tracing is this distributed context, that means you have to roll tracing out across all of those services before you get that value. So that was like kind of the problem. When you combine the amount of work with people thinking, I'm going to have to rip all this out and replace it if I ever switch vendors, it's just kind of like dead on arrival outside of an organization like Google or Microsoft or Xerox PARC or something like that, where, you know, there's just this enormous internal engineering culture that can make it worthwhile to go ahead and do that. So that was the real blocker. What I see the future is like OpenTelemetry today, but eventually observability gets so in people's mind that future languages bake it in. I'm hoping they bake in OpenTelemetry, or at least something really compatible with OpenTelemetry. I'm nervous because like language designers are cantankerous. Like the whole reason you make a new language is to make everything different from all the other languages. So I'm a little worried when it comes to observability. They're going to be like, yeah, but we're going to do it different. And then we're going to be like, but now your stuff doesn't compose with the rest of the distributed system. But anyways, it's a problem I would like to have. I would like language designers to be thinking about observability to the point that they're actually providing these like context propagation mechanisms.
Do we want to do a quick aside where we rate the most cantankerous language folks? Or no, we'll leave that. We'll leave that off. Okay. Matt, we were curious about something. You were about to ask a really good question. You want to go ahead?
Was I?
It was the one that we practiced earlier.
Okay. What's the words that I can say? What's this question?
All right.
Which one?
Is this like a surprise birthday party that's about to happen? What's going on?
Feels like it.
So last year we talked talked about like OTel in 2024. How quickly is everything moving? So, open source projects, particularly ones driven by foundations, we were talking about that earlier. Like there's so much, the clip is fast. So what's different? So if you haven't been keeping track, what wouldn't you recognize this year from last year?
Yeah, OpenTelemetry is this curious creature. I consider OpenTelemetry's unofficial mascot to be the racing snail from the Neverending Story. If you remember that movie. I do remember that. Right? Because OpenTelemetry is high latency but high throughput, which means when you go and engage with it on any one particular thing, you're like, oh my God, this is like so slow. designed by committee, right? It can really feel that way because unlike a lot of other open source projects, OpenTelemetry doesn't really get any takebacks, right? Like we, generally speaking, like if we put it out there and it gets adopted and we break it, people hate us forever. Much more strongly than like most things where if it's like new and we break it, we're just like, well, it's like new open source stuff.
Wait, no way. Doesn't everyone feel like that? Like if someone loves it and you take it away?
No. Like I feel like more so than other projects, OpenTelemetry gets punished hard for breaking backwards compatibility. At certain layers, we have to be very strict about it. The API layer in particular, the data layer, if we create any kind of dependency conflict where like this library depends on OpenTelemetry 1.0 and this other library depends on OpenTelemetry 2.0. Now these libraries won't compose because of OpenTelemetry. We are so dead if we ever create a situation like that for ourselves. So we really have to care about it.
Which probably speaks to the way that people are using it in production, or it's like they're relying on it.
It's a cross-cutting concern, right? Like there's certain aspects of OpenTelemetry around propagating context where it only works if like everyone uses literally the same thing. And so that part is like very, very temperamental and very sensitive to compatibility issues. So we just have to care a lot. Anyways, because we have to care a lot about like the first major version, we do a lot of work to make sure we've gathered all the requirements and everything like that. And like that can feel slow. So people will be like, OTel is so slow. But then we're very, very high throughput. There's so many people working on it. There's so many open initiatives at any given moment that we then also hear, you know, from the vendors that we all work at, people being like, oh my God, another change? Like, where did this come from? Like, you'll have these like kind of incoherent conversations where people are like, we can't rely on OTel to deliver stuff because it's too slow. Also, you're delivering like too many things and we can't keep up. Like, because it's both. It's like high throughput, high latency. And once you get that about OTel, then like a lot of it makes sense.
So it's particularly like how much have the goals shifted for you? So it's like from the beginning when you put those together, like where does it feel like you're at now as far as like how you expected the project to evolve?
Yeah, that's a great question. I would say it's less that the goals have shifted so much as we got through the initial set of goals. Like the initial set of goals were tracing metrics and logs integrated together into a single system and completely ruthlessly normalized and organized so that the data is very, very uniform. That was the initial goal. And finally, with logs this year, we're complete. The kind of last little cherry on top was this sort of epic logs versus events, Bikeshed nonsense that was just seemed like a rite of passage I think you have to go through when you're building a logging system. Is to like
or an event system
yeah, or a system that logs events, you know, or a system that creates events every time there's a log.
Oh yeah. Or a shed that houses bikes or a bike.
The amount of feels people had like towards whether their data structure was called a log or an event. I wish we could harness that energy and put it towards something productive. That's all I can say.
So if you distill it down though, what ended up being valuable from the decisions that were made? Because I get the bike shedding, I understand all the lead up, but eventually that yielded something. So what did it yield?
Yeah, well, I think there's something that's really interesting with OpenTelemetry is every time we tackle one of these signals that we call them, we're thinking about it. It's just like another data signal, but this is like a whole industry, a whole ecosystem, a whole set of practitioners who only over-fixate on this one data source, right? And so you're actually like bringing in a whole community when you do that. And that community has like a lot of opinions and they're not used to leveraging the other data sources available. So there's this aspect of everyone having to learn about each other's observability practices so that we can integrate and create an integrated data experience. So, for example, something in tandem with this is browser and client observability. That's something I've been we care a lot about that, but we had to delay going after it because we realized we were missing some fundamental pieces. And one of them was client code is way more kind of event focused than it is transaction focused. Servers are very transaction focused. It's all of these totally independent transactions happening at the same time. Each transaction's a completely separate user. You don't want these transactions interacting with each other, but they do because they're competing for resources. And this is the source of like all trouble, you know, when it comes to like server side observability is the independent transactions competing for resources is like mostly what we're dealing with. Then you go to the client side and it's all one user. Everything going on in this machine, on this like computer is all related to one user and one flow of consciousness. And even the way that's constructed in terms of like code architecture is more of this kind of like event reactor pattern than the kind of like transactional like context switching pattern that you see in servers. And we just were not ready for that because the last thing we were tackling was logs, right? But this is like a very event forward world. It's also a world where like we assume the resources available to a computer program don't change because on a server, they don't. If you're going to change the resources available to a program on a server, you usually turn the machine off before like adding more RAM or something.
Right.
But on the client side, especially mobile devices, the resources are changing all the time, right? Like the app might be like backgrounded and now it's in background mode, it's totally different set of resources available. Like the network stack might switch out on it, right? Like Wi-Fi versus cell. And you need to know about that or your observability data is going to get really muddy, right?
Yeah.
Right, you want to do apples to apples comparisons, which means you have to actually track these moving targets of, right, being like it's fast here but slow here, and this is Wi-Fi and this is like bad cellular connection. You need to be able to differentiate all of that if you want clean data. And we just like weren't ready for that. So that was a place where we had to kind of like go back to the beginning, get everything done. And now we're like finally done with that with logging. But it was a bigger push than I thought it was going to be because on the surface, logging seems so simple. It seems so simple. It's actually the simplest of all the data structures we've tackled. But weirdly, that made it the most difficult to deal with because it's just bags of dictionaries. It's just dictionaries of dictionaries of dictionaries. And like, why put anything anywhere? Because you could put everything everywhere because it's just dictionaries. So that weirdly made it harder to figure out like what our model was going to be. If we want our model to be like highly structured and predictable.
Did it start to resemble something that had been like created a million times over, or is it something new?
It feels new, in the sense of like logging traditionally has been very, very, very unstructured, right? Like logging traditionally was just like a string that you splatted out somewhere. And now we're trying to.
That's how I do it still.
Yeah, it's like got here. This code should never execute. Like whatever the log message is.
Usually it's just monkey. It's just the word monkey. Because I just need to see where it shows up in the other logs.
Yeah, I used rabbit. Follow the white rabbit was always my
that's
little,
good.
Yeah.
Yeah, I'll use that now. That's better.
Right. But now we want something very, very structured because we don't want to be making random logs. What we want to be doing is like having a model for how we describe this library or this data service or whatever the heck it is. And we have a model and we wrote it down as what we call semantic conventions, right? So we're like, these are the events that this system will admit. Here's how you should be using these events to create like alerts and dashboards and things. Like we want to be very structured. And then we want these events to be organized, right? Like we want them all to have like a type, which we call the event name. And we want it to be like, if you see one event with this name, 100% of the other events that have this name will have the exact same structure. Mm-hmm. They'll have the same attributes and the values of those attributes will be the same type of data. It will always be a number. It will always be a string, right? So getting that level of rigor into to logs are what arguably makes it more like an event. So that's where we landed, was we have a logging system, and if you name these things, then they're events. If they have a name and a classification and you're doing all the work to be super organized, then you can call it an event. And if you're not being super organized, and if you don't have a rigorous like system,
then it's a log.
Then it's a log. Then it's just some, and you know it's one of those because it doesn't have an event name. It's just like, oh, this is just some from, you know, the person's like application logs from like 10 years ago.
Well, now kids can't listen to this. Thanks, Ted. You just broke
sorry.
ours.
We'll have to cut that one.
Well, I just think it probably held back that generation from adopting OTel. What you've just done there, Ted, with that one word. No, but hold on,
Wait, is there before you ask Matt, is there a third? So there's logs, events. Is there a third pillar?
Well, these would both be the same pillar.
No, okay, fine.
Yeah.
I'm just going back to the whole creating pillars that were unnecessary. So now we need pillars.
But it's so, you know what people cared about? What people cared about was how important their thing was. People really didn't like the idea of calling it logs because their events were so very, very, very important to them. If they were coming from a domain where like this is the primary observability tool, like browsers or whatever, like they're events, and they're events because we care. And then in domains where like your average log has like a negative value because it's useless and it costs money, like then it's like we call them logs to indicate that like the value is like super low. And it's like it's not that they're even structured differently. It's just like, did we care about them or not? If we cared about them, that community wants to call them events, and they don't want them mixed up with the logs because that sounds like you mixed up my precious data with stuff that doesn't have a lot of value.
with something that you flush down the toilet.
Right?
Yeah. Whereas an event is a big thing you go to. Yeah, this works.
Right? Like, and
you get dressed up
we're
for.
just like,
Nobody gets dressed up for a log.
and we're just like,
It's the
but
opposite
like,
of anything.
could you look at the data structure and be like, are event names okay? Is everyone cool with names? And everyone's like, yeah, we're cool with names. We just want to argue about.
What if you just have a log line that has, it's no event name, but it's just a log line, but it just says the word event? What's that?
That you logged the word event. It's okay.
Does that, Ted, this is an honest question. So all right, this is how I'm following as a dummy in the room. So kind of this idea of like you had these three pillars, it was sort of like a false, like kind of a false setup in a way, almost like you started shipping your org chart and you tried to put things into these distinct teams, these distinct systems and make it work. And OTel is kind of pushing past that a little bit. And it does sound like the log event conversation then created this concept of it's like almost like the value, it was like a value conversation. So then does that value conversation get applied to things beyond logs and events? Meaning like, would you have value discussions around, metrics? Would you have it around tracing? Like, is that a new way of thinking about all these things?
In a certain way, it is. The part that we haven't thought about too much is how people use this data. Like, in a sense, we do think about it, right? Like, we do care about the cardinality of some of these attributes, right? We know that spans and logs are going to get turned into metrics in some way. But because we don't have a backend and we don't have like an OTel UI, I think there's been less of a focus on when defining these semantic conventions, are we also defining a dashboard, a set of alerts, a set of playbooks? I think it's like very feasible to be like, here's like the default observability stack for HTTP stuff, right? That's the OTel approach. It's not logs or metrics. It's like HTTP and networking information. How should you set up all of that? Database queries. How should you set up all of that? Infrastructure stuff, Kubernetes. How should you have all of that set up? I would like OpenTelemetry to kind of go back in and start thinking more about the dashboarding kind of playbook aspect of what to do with this data. I think there's an opportunity to not totally standardize it, but at least make sure there's at least one standard use case And again, like the browser is a good example of this. Like we're on the browser right now. We're trying to define browser observability. So the first thing is like, well, what is the browser doing, right? The browser itself has a bunch of events that it fires when it's loading a page, and you want to like record all of that so you can replay that page load. But then it was like, but we also care about network package size, for example, right? Because mobile networks, like we want the data to be cheap. So that instantly caused the question to be like, well, which of these attributes are we using for what? Because in order for something to go into this precious payload that we want to be very careful about the payload size, every attribute needs to like buy its passage by explaining how it's going to be used in the background. And so that felt like a good step forward. I'm like, this is a great practice I would like to export to the other SIGs of like, there at least being one dashboarding or one kind of experience that we write down as a justification for adding this attribute the way that we're adding it.
Yeah, I love that. I think it reminds me a lot of how the Go language is also kind of managed. They also have the backwards compatibility promise of V1. And yeah, I don't know if we want to get into the language, which one's the best one, or
I heard Go people are cantankerous.
I don't know if they are now. I wish you hadn't said that, boy. Something like that. Imagine I did a good thing. But Ted, like,
Go's terrible. Go's our absolute problem child. And I say that as someone who has managed a lot of teams writing Go and has written a lot of Go. There's some aspects of Go that I really like.
Is this genuine?
This is genuine.
Oh, okay. All right. I don't know if you're just giving him a run.
Yeah, there's some aspects of Go that I really like on a personal level. I really like that it's focused on readability, right? Like they're very restrained about the kind of quote magic that you're allowed because they really care about readability. You should be able to like dive into some code base you don't know anything about and read the Go code and understand what the system's doing. And I think that's fabulous and like A+. But there's a bunch of aspects where Go feels like very slapped together from the perspective of people trying to manage these cross-cutting concerns like observability, where context propagation in Go is like the worst, like by far compared to other languages.
Because it's explicit.
Because it's explicit, and it's explicit in a language runtime that's like the level of abstraction of the language runtime means if we try to kind of auto-instrument, if we try to hook in from a low level using low level tools like eBPF or LD preload to like automatically install all this stuff, it doesn't work in Go. It's dangerous to do it in Go because there's just so much machinery sitting on top of those where those tools hook in and where the actual user land stuff is happening. It's like a dangerous proposition. So we have these tools that we're trying to leverage right now to really improve the installation experience in a bunch of languages. And then like Go is the language that doesn't work. Go is very brittle from a backwards compatibility concern. So a lot of our design concerns involve kind of putting stuff into the spec in a way to make sure we're not going to break Go. So I really, really love our Go maintainers. They're really fabulous, but they have a harder job, in my opinion, when it comes to like spec and design. They have to pay attention harder than the other maintainers, and they have to be more involved because they run into more tricky situations in Go than in any other language. And I feel like I can say that definitively at this point because it's been years of working with all these languages.
And it's like the internals, isn't it? It's like when you build it, there's bits going on in there, and that's the stuff that's more complex.
The Go often, I describe Go as like a box where the sides don't meet. Like it has all of these different features, but then when you really try to flex those features for their intended purpose, you realize you run into some problem with where it interacts with like another feature. So in Go, you want to use interfaces as a way to have loose coupling between, separate systems. Classic thing, right? Classic problem, classic solution. Loose coupling between separate systems. But then you want to have like compatibility evolution where like I have this interface and I want to safely evolve this interface. What can I do safely in Go that won't break backwards compatibility? In every language except Go, adding a thing to the interface is generally considered a safe or like a decent practice. In Go, if you even add a new method to an interface, that should be a V2 in like Go, like best practice in lore. You should major version bump if you even add, because someone might be doing some dynamic stuff with that. So they added interfaces to manage like safely loose coupling systems, and then they added dynamic programming, and then these two things don't think about each other. And so now your interfaces are so locked down, it's like touching them at all means you have to do a major version bump. But as we talked about earlier, if we ever do a major version bump, even if we didn't change anything, if we just did that, we would be creating this like compatibility disaster for ourselves, where some packages would depend on the 1.0 and some would depend on the 2.0. And now you can't import those packages into the same place. So we have to like violate Go's principles of like versioning and add methods to interfaces and tell people don't do dynamic stuff with this interface unless you're willing to like keep up to date with minor version bumps. And then everyone in the language is irritated with us. And we're like, yeah, but the other problem is worse. It's not our fault that all these things don't like line up the way they do in other languages. Like it's just Go didn't think about this stuff when it was put together.
Yeah, well, even not doing dynamic stuff, if you add something to an interface, you have changed then the contract, and any calling code wouldn't necessarily build, right? So, yeah.
Right. But so that's the thing we say is like, as an implementer, if you implement these interfaces, you're required to keep up with the API, right? OpenTelemetry has this very nuanced approach to backwards compatibility, and one of the kind of like pressure release valves we give ourselves so that we have room to like actually deal with stuff is we say the SDK has to keep up with the API. So we're going to ship new features. That's going to go into the API. Instrumentation is going to depend on those features. People are going to depend on that instrumentation. The SDK has to be able to handle it. We don't want to be trying to we don't want to play 5D chess with ourselves where we're like, what if we add this new feature, but someone runs that with an old SDK that's just going to ignore those API calls? Like, how do we deal with, we're just like, we don't. The SDK has to keep up. So if someone wants to build their own SDK, they can totally do that, but they have to do what we're doing and like keep up with the API. You have to be willing to do that for your users. So, which again is like slightly weird, but we need it in order to like actually deliver the compatibility guarantees that our users need.
Yeah. Oh, that's very interesting. I didn't realize that.
It's so much more straight. There's like a path forward in like every language. There's like that community has a path forward for dealing with this because these are like normal things. These aren't like OTel observability things. And then in Go, it's like, it's just this minefield. It really feels more like that in Go than in other languages. And I say that as someone who likes writing Go code.
What's the easiest language then? It's just going to be the one that's just lets
Java.
You do anything.
Java is the easiest language because Java is the language that thought about this the most and has the most overt facilities available for doing exactly what you'd want to do, which is to just dynamically attach all of this stuff in a safe way that doesn't get in anybody's way or require any effort. And like that's like an explicit concept in Java, right? They have a whole agent concept, right? And like the whole dynamic programming universe. And this is all like very normal things to do with it. So Java is the easiest because like there's the most intentionality available in that world.
So should everyone switch back to Java then, you think? Because there's a lot of go around and it's
I heard Rust. I thought Rust was cool, but now I just heard about Zig, which is like a new way to write low-level C stuff, and that sounds way hipper than Rust.
Yeah, I heard it's easier to learn.
Yeah, it sounds like it pairs with my record collection. So I think I'm going to become a Zig programmer as my next.
Got a lot of David Bowie.
My next bit. Yeah.
I wonder if David Bowie used OTel. He was quite into tech.
Mm-hmm.
That's true.
Yeah. Starman.
At the estate of.
Yeah.
Yeah, the Starman is just because it did really well on GitHub one time, and one of his projects took off. that was the inspiration behind that song, apparently.
I'm updating Wikipedia right now.
I'm the GitHub Starman, that kind of thing. And hopefully that doesn't make it into the podcast. If it does, dear listener, you'll really come to realize how little say I have in what makes it in or not.
Do you have kids?
No, I don't have any. Do you?
So that's why we're getting this, right? It's like there's no other outlet for this behavior.
Okay. Great. Good. So, have you read my performance review? That's very true, though. I sometimes find myself being really silly, and then I think, this is not meant to be like this at this age. But just don't worry about it. How tempted were you to call it OTed instead of OTel?
Oh man, if you thought the logs versus events naming Bikeshed was epic, naming OpenTelemetry, that was epic. That was this epic.
Really, it's such an obvious name now. It seems,
isn't it? Isn't it obvious now? At the time, it was not obvious. Everyone hated the name at the time. Absolutely hated it. It was like the worst. The beginning of OpenTelemetry's design by committee disaster, where everything's a disaster, and then like 6 months later is like totally fine, and like everyone's like, why did anyone have a problem with this? OpenTelemetry was that name.
What were the other ones though?
Round and I can't
find
the spreadsheet anymore. There's this epic spreadsheet. My favorite one. This was said with a straight face. By another leading contributor was, we have like standard in, standard out, right?
Like this.
So like why not have standard monitoring? So we should call this new system STDmon.
Yeah. I think now it's called STI Mon.
And we're not calling it STDmon. Like, what the
This is why the question didn't get answered last year, because we talked about this and you're like, and there's a spreadsheet and you can't find the spreadsheet. We voted on a name. See, but now everyone probably swore, but this is like all conspiracies, right? There's always a leak before someone dies, and now we know.
There were a lot of really elegant and interesting names, but
to be fair, Ted, you've ruined standard in and standard out as well with that joke. Yeah.
It's like, oh my freaking God. No, and that was like, it's like, what? We've already got these two and no one's complaining about them. I'm like, you're going to be drawing attention to something that we want to forget about. But at the end of the day, boring one out because we're like, we want to be a standard, actually. And so even though there were some like interesting fun names, we're like, it actually works against our best interests. The more this thing sounds like a Pokemon, the less it sounds like a boring standard. And we actually want people to treat it like a boring standard. And so OpenTelemetry. And then people are like, it's so many letters. And then we came up with OTel like 3 days later, and everyone's like, that's fine. And
I want to, if I get anything from, or if anyone listens to this, I want them to join the community calls as much as I do, because I feel like it's like joining a reality show, and like you get to like listen to everyone kind of like flip out, and you're like, that's fine. And then we just make a bunch of good decisions, and then life moves on.
Big ideas loosely held. Yeah, like we have these big bike sheds, and then we do the obvious thing and move on. And that's just how it works.
So I do want to make sure we talk about this zero touch installer, because talking about how becoming a standard and teams adopting it and the ease of adopting it, Yeah, what's going on there? What do you want to happen over the next few months there?
Yeah. I mean, so long term, I would love for observability to be a first class system. I think we've done a lot of work on OpenTelemetry to build the instrumentation APIs in a safe way for it to get embedded directly in libraries and data services. So the future I would like to see is that no one has to install any OpenTelemetry instrumentation anywhere. Because when people write software, they're thinking about how their software is going to be run, and they're instrumenting it, and they're shipping a playbook for the people running their software, letting them know like how to actually tune the configuration parameters that they gave them and all of that. So that's the world I want to see, is like people right now don't think about observability. And I think in part it's because they don't have tools to instrument their own stuff. It's like, you can't, it's like hard without OpenTelemetry. It's actually hard to do native instrumentation. So long term, I would like to see that. And I would like to see everyone become more of an observability expert as a side effect of that.
Do you think AI is going to help us get there with that?
Do I think AI is going to help us get there?
Matt, what's AI?
Artificial intelligence.
Okay.
Yeah. In the meantime, we're sticking with AAI, artificial intelligence, which is just people who know how to program. But eventually,
they're all going to be dead one day.
Eventually, we'll get the real thing. The real artificial intelligence will come in.
Oh, okay. All right, fine. So honest question then. Do you see AI in some sort of, 2 or 3 iterations along, just completely upending anything that you're working on here? Or do you think that it, like, because it's a little more structured, because there's more thought in how the data is used, and it becomes an accelerant somehow? Or is this all just silly to even talk about?
I mean, I feel like with AI, it's like 90% chance nothing changes except our tools are more complicated, with a 10% chance that the world ends in some kind of Skynet Terminator disaster, and like very little in the middle. I'm very bimodal in my,
Can you imagine
my AI predictions.
If the moment in time, the Terminator moment in time when we went back, is when you all decided for events, and they're like, well, that's
yeah. We're gonna call it events, and like Arnold bursts into the
he's like,
room.
no.
He comes in, it's like, as if Java's better than Go.
Yeah. I'll be back once this has compiled.
I guess taking the AI just back for a moment, for the install, is there anything, I don't want to lose this, is there anything that you would say for, let's say, someone who's rolled out OTel, like in their teams are starting to change or shift focus? Like, how would you tell an early adopter team within a company, like, to help it get wider? Like, is it, what would you say to someone?
Yeah. So the thing about installing OpenTelemetry that makes it hard is there's like a catch-22, which is to know whether or not you've done it correctly, you would have to know what OpenTelemetry does, right? And like, how can you know what OpenTelemetry does if you've never interacted with it before? So, I mean, this is like any complicated piece of software, like that first installation experience is like a difficult one to manage, and you really want to have a product experience around. Installing this thing is really less about you doing work for it and more about it teaching you how it works. Like when you like start a new video game and like the very first level just happens to like teach you what the different buttons do, right? Like you want to have that kind of like productized experience when it comes to installing OpenTelemetry. And we have put zero effort into that, right? OpenTelemetry takes the opposite approach of like, it's a box of Legos, because we want to make sure that we're not locking you in to like our implementation, right? Like if you want to use OpenTelemetry tracing, but you still want to use Prometheus for metrics and like your old application logging system, it's very straightforward to mix and match. But the side effect of that is like it's a box of Legos, and you have to know how to mix and match all these things. So we're always interested in improving the docs, improving the installation guides, providing things like the OpenTelemetry demo application so you can go look at something that's been instrumented and get insights there. All of this stuff, but really what we'd like to do is to have you do nothing at all, just like push Just like installing any software, be like, step 1, install. Step 2, it works. Step 3, you use it. Step 4 or 5 or 6, maybe you start learning the details as you want to start to like mess around with the knobs and stuff. All right. So can we do that? The answer is absolutely yes, we can do that. And it involves really getting into the weeds with a bunch of packaging tools that we haven't focused on. We've mostly been focused on language library level packaging. So you have a bunch of libraries that we want to install instrumentation for. So we have a bunch of instrumentation packages in Python or Go or Java. And then there's something in that language that's specific to that language that knows how to like scan what you have in your app and find the instrumentation packages that match what you have and then like download them and install them. We do have some kind of automated monkey patching thing in many languages, but it's different for every language. Some languages like Java, it's normal to do that. In other languages like Python, it's kind of weird, right? Like you can do it in Python and Ruby and JavaScript, but it's kind of weird. It's not a normal thing. So even explaining to people how to use the like weird OTel bootloader in like Python is like still some weird new thing they have to learn. So we would like to use a low-level tool called LD Preload, which is like a Linux bootstrapping tool to actually like get in there and automatically install all this stuff for you. So that takes it from like a language specific installation process to and elevating it to more of like a traditional kind of like sysadmin Linux package management experience, you know, where you're just like, you know, brew, you know, keg, tap, OTel, and like all the OTel stuff just shows up and like it scans your system and sees everything running and just binds to all the things. And then you start managing that whole set of stuff it installed using op-amp, our control plane protocol. So that's actually like a new set of software, something called the OTel injector. We're also looking at OB, which is our eBPF solution, as like another thing for getting like red metrics and like network profiling out of everything. And then we're looking at the operator for like Kubernetes and like host metric stuff. And just trying to bundle all of that up into a kind of like OTel. I would love a name for this thing, you know, but I don't want to call it the OTel agent because agent is this like utterly horribly overused word, right? But it's like the OTel installer, right? It's like the package installer that would let you as like the IT operator at a big organization, you would have the ability to go in at a low level and just like run this thing everywhere. And then OTel would just get booted everywhere and no one would have to lift a finger.
I think you can call it like a virus, right?
Yeah.
You want it to have this like viral.
We use crypto miners currently. We have like OTel has a dark web contract to get it as like a ride along.
A Trojan OTel.
Yeah. So it's mostly phishing attacks is how we expand our reach.
It's one OTel's like, I need you to buy gift cards for me.
Yeah. So many OTel gift cards.
But it's one touch probably, not zero. If it's zero touch, that's like your Apple putting U2's new album on there.
That's where the AI comes in. It knows. It knows before you know.
Speaking of knowing stuff, where can people go to learn more? Because Ted, you did an ObsCon talk. Mm-hmm. That's on YouTube, so people could check that out. How do they find that? Google? I mean, search for it.
Yes. Yeah. Well, yeah. I did a talk at GrafanaCon. ObsCon is coming up, and I'll have a talk at ObsCon. I believe it's called Deploying OpenTelemetry with Grafana, and that will actually be kind of a deep dive into this installer and this kind of like world of like here's what we were calling like a Maslow's hierarchy of need, but it's like Ted and Ed's hierarchy of observability needs, and how OpenTelemetry is going to try to like improve on the value there in terms of like automatically installing the most important, widely available stuff first, and kind of like what a roadmap looks like for tackling this installation experience.
That's great. And I was speaking in past as though the event had already happened, because when this goes out, it's already happened.
Right.
I don't want to sound like Doc Brown, but you're not thinking fourth dimensionally.
1.21 gigawatts.
Yeah.
Yeah, ObsCon. Yes, because we're in the future now, and that's already happened. Exactly.
Yes. Yeah. And you're going to be FOSDEM too, right?
Yes. So this will also be out by the time this is released, but we will be throwing an unconference called OpenTelemetry Unplugged, or OTel Unplugged, as part of FOSDEM Fringe. So that'll be in Brussels in February.
What are you going to do? Just not have the screen, just not have anything plugged into the projectors?
Nothing plugged in. Yeah, we just go around, we unplug, we unscrew all the lights, and then we just sit in the dark and the silence.
And think about what you've done.
Breathe, meaningfully.
Well, that's what our listeners can now do, because actually that is all the time we have. And I assume once the Big Tent podcast's finished, that's what they do anyway.
Well, they just need a moment of silence after.
Yeah, I do after hanging out with you, Matt, for a bit. It comes across as mean. When you're mean to me, for some reason, it's all jokes and fine.
What do I mean to you? Did I say something mean?
No, never do. Too nice, I think. But anyway, we haven't got time for that. So thank you very much, Ted Young.
Yeah.
Thanks so much for joining us. This was great.
Absolutely. Yeah. Good times.
Yeah, and we'll see you next time on Grafana's Big Tent.